For our next topic, we're going to be talking about parabolas. Let's go ahead and give ourselves a sketch of some important components that we're going to be taking a look at when we graph some of these equations. For this setup, let's pretend I have a parabola that opens downward. One of the pieces that we're going to be looking at is the vertex of our parabola. For right now, I'm going to go ahead and let that vertex be at the origin in this image. I'm going to let V represent my vertex, and keep in mind the vertex is going to be given the coordinates HK. H is going to represent the X value of that vertex, and K will represent the Y value of that vertex. We're also going to be taking a look at what's called the focus. I'm going to let the letter F represent my focus, and your focus when you're talking about a parabola is always going to occur on the inside or the curved portion of your parabola. We're also going to be taking a look at the distance from our vertex to our focus, so we want to measure how many units this would be. I'm going to be using the letter A in my examples to represent the distance from the vertex to the focus. If I count A units in the opposite direction from my vertex, I'm going to end up at a line that's called the directrix. And one of the neat things about parabolas is that this distance from your directrix to the parabola itself, any point on it, as long as it's perpendicular right here from the directrix to this dashed blue line that you see, this distance is going to be the same from my point on the parabola to my focus. Obviously, my drawing here is not drawn to scale, but just know that that's kind of the pieces that would be equal to each other. If I move this point outward here on my parabola, this distance from the directrix to my parabola would then be the same as from this point over here to my focus. So let's go ahead and take a look at just some basics with regard to parabolas that you already know so that we can tie it into some of the equations you're going to see in this section. I'm going to be tying some of these pieces together, and let's include some sketches. So we've taken a look at the equation y equals x squared. You know that's a parabola that if I sketched it would be opening upward. If I had the equation y equals negative x squared, that would be a parabola that opens downward. If I take a look at my equation x equals y squared, this would be a parabola that's going to be opening to the right. And if I look at my equation x equals negative y squared, this would be an equation that is opening to the left. Now, a couple generalities here, right? My equation that opens up or to the right, notice that all your terms there are going to be positive. And if my equation is opening either down or to the left, then I'm going to end up having a negative in my equation. Now, I went ahead and added some extra equations over here on this right-hand side that we're going to be seeing in this section. These equations that you see are assuming that we have our parabola centered where that vertex is at 0, 0. So keep in mind, if my parabola is going to open up, my general form is going to be x squared equals 4ay. Notice that's kind of the same format as this one. Terms are on different sides, but obviously this would be the same thing as x squared equals y. Right? If my parabola is opening downward, I have x squared equals negative 4ay. And if it were opening to the right, y squared equals 4ax. And if it opens to the left, y squared equals negative 4ax. Now, let's take a look at these exact same formulas, but talk about what happens when the vertex is located at something other than 0, 0. Let's give it just an h and a k value so we can talk about the general forms first. So if we assume that our vertex is at the point hk, let's talk about this first equation, right? I had x squared equals 4 times a times y. my h and k values, remember they represent your x and your y values off your vertex. So my formula is going to edit here to x minus h, the whole quantity squared, equals 4a times y minus k. Your x value will always appear inside that set of parentheses with the x because it's your x term. Your k value will always be with the y value inside that set of parentheses because it represents a y component. Keep in mind these minus signs are always going to appear inside your formulas. So we've done the same thing for each of the formulas there, assuming that we have the vertex at something other than the origin. Keep in mind when you're coming down here, you'll notice when I'm talking about parabolas that open to the right, inside my parentheses here, it's a y minus k value, right? That k value would be the y component. So make sure the right letter is going there inside your parentheses with the y value.